Hey, Algebra 2, welcome back. Here is 7.5, apply properties of logarithms. And so our objectives are to use logarithm properties to, well, already a mistake. This should say expand. To expand / condense log expressions, and we'll see kind of what that means here in our first few examples. And then we're going to evaluate logarithms using the change of base formula. Okay, so the properties of logarithms that we have, there are three that we're going to want to know. And we have their names. We have product property, quotient property, and then the power property. Okay. And so what these properties are going to help us do are to either take a logarithm and rewrite it as multiple, or rewrite multiple as just a single logarithm. And depending on the situation, we're going to want to do one or the other, right? And this will be especially useful to us when we start solving equations in 7.6, okay? So the product property, we have log base b of m times n, or sometimes you're just going to see it written as mn, okay? And that's inside the logarithm. We can rewrite that as log base b of m plus log base b of n. Now notice that these are two logarithms being added. It's not like this is not inside one logarithm. It's log base b of m and then plus log base b of n. Pretty much what's happening is that when you have a product or multiplication inside of a logarithm, I can split that logarithm into two through addition, okay? Likewise, if I have two logarithms being added like this, I can rewrite them as a single log, multiplying the insides together, okay? So then the next property is the quotient property. If I have two things being divided inside the log like so, then it's going to be pretty much the same thing, except it's going to be log base b of m minus log base b of n, okay? And so same idea, right? I can go forwards or backwards with all of these properties. Last thing is the power property. If I have log base b of m to the n power, then what happens is that I can bring that power, that exponent, down to the front, and it ends up being like this. So it ends up being n times this logarithm, log base b of m. Okay, so pretty much what happens is that an exponent comes down to the very front. Okay, and so those are our three properties. And so let's just dive into a few examples. Okay, so we can use these properties to either expand or condense. And so when we say expand, that means we're going to start with one log, rewrite it as multiple. So here's our first example. Expand the following logarithms. We have log base 6 of 36x squared. So if we look inside, the kind of first thing that jumps up at us is that we have 36 times x squared. So that's like our m and our n. So immediately we see the product property. And so what we're going to be able to do is rewrite this as log base 6 of 36 plus log base 6 of x squared. Okay, so that's our first step. We notice that we have 36 times x squared. That's kind of like the outermost thing that's happening. And so we write it like that. That's our first step in expanding. Now, notice that there's one thing we can do with each logarithm. What can we do with this first one? Whenever you have log of a number, always ask yourself, can I actually evaluate that? Because if you can, you should, okay? So log base 6 of 36, 6 to what power gives me 36? That would be 2, okay? And then we move on to the next one, plus log base 6 of x squared. Notice that I have an m to the n situation here. So what can I do? Using this property up here, I can bring the power property. I can bring the n down to the front. In this case, I can bring the 2 down to the front. So this becomes 2 plus 2 times log base 6 of x. Okay. Now I want you to note, because a lot of whenever I've taught this in the past, we've been kind of inclined to do this. We cannot, this is not saying add the 2's right immediately. Like we do not add those two, okay? This 2 right here is by itself, it's all alone. This 2 is attached to log base 6 of x. So this is one thing right here, and this is one thing. All right, so we don't add those 2's together, even if they were different numbers. If this was like a 7 plus 5 log base 6 of x, I wouldn't do 7 plus 5, okay? Kind of think of it in a way, for example, like if I had 4, or if I had 2 plus 2x, you wouldn't add these 2's together to get 4x, would you? Right, those, you wouldn't do that. So it's kind of a similar situation here. So because of that, this is fully simplified. This is our full answer, our expanded expression. So this right here became this. All right, let's try another one. Log base 4 of x divided by 3y. I put parentheses here just because it's a fraction. You don't remember, we don't always have to have the parentheses there. You won't always see them, but just in case, like sometimes you will, right? So here, the first thing we see is we see m divided by n, right? This x divided by 3y. So we're going to use the quotient property that says that I can just subtract two logs, one having m, one having n. So I have log base 4 of x minus log base 4 of 3y. Okay, so now look at your logs, see if you can keep going. Can I simplify this one? No, because it's x. I don't know what x is, right? Well, the second one, yes, I have 3 times y. So I can split this logarithm up into 2. One thing that you want to be careful of is that this logarithm is being subtracted. So if I separate this log into 2 logs, I'll need to make sure it's in parentheses because this negative will apply to both logs in that parentheses. So log base 4 of x, that one just carries down, minus parentheses here. Log base 4 of 3, we can treat that as our m, and then y as our n. So log base 4 of 3 plus log base 4 of y. Okay, so then that is from expanding this one, okay? But I put it in parentheses because I got 2 logs from it, and because there's a negative. If there's a plus here, if this happened to be plus, you could still do it in parentheses. It would just have no effect. We would just be able to drop the parentheses. But here it's especially important because we have a negative. That negative will need to get distributed through. And so let's just do that right away. Log base 4 of x minus, now here, 4 to what power gives me 3? Not a power that we are acquainted with, not one that we can think of right off the top of our heads, right? That one we would need to try to put into a calculator to figure out. So we're just going to leave it like that, log base 4 of 3. Then that negative gets distributed to here as well, minus log base 4 of y. Okay, so here is our answer. Okay, sorry for the crooked line. So then here are our expanded logs. Sometimes you'll get a number out of it. Sometimes it'll just all be logarithms, okay? We can also go backwards. We can condense, which means that we want to rewrite these logarithms into a single log. Okay, so when we see condense, that's what you should think. Okay, I need to rewrite these into one logarithm. So let's start with the first one, 2 log of x plus log 11. If we think back up to our properties, notice that none of them, unless it's the power property, neither the product nor the quotient properties, there's no numbers in front. Notice how they're all just log. Okay, no number in front. And so that's gonna have to be true if we want to use those properties, okay? So I see plus, which means, oh, I kind of want to use the product property and combine these by multiplying the insides, but I can't do that until I get rid of this 2. And I can get rid of that 2 by using the power property. I can bring this 2 into the exponent of the x. And so that becomes log of x squared plus log 11. Okay. Oh, now I have, no coefficients, no number in front. Now I can go ahead and use that property. When I see plus 2 logs, that's going to be taking the inside. So in this case, 11 and x squared and multiplying them. So I get 11x squared. And that's it, right? Our goal was to rewrite it as just a single log. And so that's all we have to do. Okay, let's do the same thing with part B. 5 log base 7 of 2 minus 7 log base 7 of x minus 4 log base 7 of y. Now, when you have multiple, when you have two or more than just two logs that you want to condense right into one, start with just the first two. Okay, just work your way from left to right. Because our properties, we can only work with two of them at a time. So let's do that. Condense this into one log, and then we'll have two logs remaining where we can use the property again. So let's start here. I have 5 log base 7 of 2 minus 7 log base 7 of x. And then even before we can just work with these two, notice that all three of these have a coefficient in front. They have a number in front of the log. So I can use that power property. So let's start there first, actually. So I can take this 5, make it the exponent on 2, log base 7 of 2 to the 5th power. But we know what 2 to the 5th power is. That is just 32. So I'm going to write this as 32 minus this 7 will become the power on x. So I get log base 7 of x to the 7th power. And then minus this 4 becomes the power on y. So I get log base 7 of y to the 4th power. Okay, now let's go ahead and work with these first two logs. Subtraction, so it's the quotient property. It's going to be m divided by n. So I get log base 7 of 32 divided by x to the 7th power minus log base 7 of y to the 4th. Okay, so now look, I have two logs, and now I can just use the property again. Here in this case, it's still subtraction, so I'm going to use quotient property. So it's m divided by n. Okay, it's kind of weird to work with the fraction though, right? That's going to be this divided by y to the 4th. So 32, I'm going to do it on the side over here. 32 over x to the 7th divided by y to the 4th. Another way to think about that is 32 over x to the 7th times the reciprocal, 1 over y to the 4th, right? Division is the same thing as multiplication by the reciprocal. Probably a lot easier to think of it that way because now I can just multiply across. So this becomes log base 7 of 32 times 1 is 32 divided by x to the 7th times y to the 4th. And there's our answer. Okay, not too bad. All right, so there is a few examples on expanding and condensing. Now we have one last kind of subtopic to cover, and it's the change of base formula. Okay, so now sometimes, if you recall, when we calculated logs or evaluated logs in 7.4, we could really only do the ones that were nice numbers, right? Like if it was log base 2 of 8, they had to be powers of the base, right? Now, if it was something, for example, like log base 3 of 4, there is no way I can raise, there's no numbers that I can think of 3 to the power of those numbers that would give me 4. It's going to be a weird number that we don't really know right off the top of our heads. Well, the change of base formula can actually help us to find that number, right? Okay, that's kind of the main use of the change of base formula. It's to help us with logarithms that we can't on our own calculate, okay, or evaluate in this case. So here's the formula. Here's kind of the generic one, and then we'll kind of write one that is going to be more useful to us. So generically, it's going to be log base c of a. If I have some log with base c and I have a as the input, then I can choose a new base, let's say b, and so that'll be log base b of a divided by log base b of c. Okay, so you can think of b as the new base. Okay, the base that we want. And so strategically, how can we make this so that it's useful to us? Well, remember on our calculator, we only have log base 10 and the natural log. So we can format this in a way where, okay, this is going to be useful to me because now I can plug this into my calculator to figure it out. So if I have same thing, some log base c of a, c is a base and a is a input, and I don't like how they're related. It's like 3 and 4, right? No power that not any number that I know of, I can raise 3 to that number to get 4. Something like that, right? What I can do is I can do it as log base 10 of a divided by log base 10 of c. Equivalently, and you'll get the same answer if you do it this way, I can do natural log of a over natural log of c. Okay, this is pretty much the same thing as this right here. It's just now I've specified, I don't really care for any other value of b aside from 10 and e, the number e, right? And so that's going to be a lot more useful to us when we put this in our calculators. Let's see what all this means in an example, okay? So use the change of base formula to evaluate the following logs. Log base 5 of 8, let's start there. So using my change of base formula, what I need to do so that I can calculate this or evaluate it, I can rewrite it like so. Log base 5 of 8, 5 would be my c, 8 would be my a. So it becomes log of 8 divided by log of 5. You can think of it this way, it's going to become log of the bigger number divided by log of the base. Log of the input divided by log of the base. Log of the input, so equals log of 8 divided by log of 5, the base. All right, and so we don't have to do it both ways, okay? You can pretty much choose which one you want because both of them will be in your calculator. I'm gonna have log base 10 in my calculator as well as the natural log, but you do need to choose one, right? Choose your favorite in this case. And so I'm gonna want to, when you guys are doing work for this, I want to see you do the rewritten version and then go ahead and put it in your calculator now that you're able to. Okay, so you can do it on your own scientific calculator, or you can do it in Desmos, whatever is going to be easiest for you, whatever you have access to. And so let's go ahead and calculate that. Log of 8 divided by log of 5 is equal to, let's do 3. I forgot to tell you, round to 3 decimal places. Okay, so from here we get 1.292. 1.292 is our answer. And so what this means is that, this is the value of this logarithm. That means that 5 to the 1.292 power, and I'm going to put approximately here 8 because I rounded this, so it's not exactly true, right? I can't put equals here. But when I raise it to 1.292, I'm going to get somewhere near 8, okay, because I rounded this number. But we found the answer to this question, right? Because we were wondering 5 to what power gives me, oh, I don't really know. That's kind of it's a weird number. It's not a nice number like 1, 2, or a half, or -5, right? Okay, so now let's do the next one. Log base 20 of 9. Let's use the natural log this time. So it's going to be the natural log of the input, ln of 9, divided by natural log of the base, natural log of 20. Okay, using our change of base formula. So then now let's put in our calculator. Natural log of 9 divided by natural log of 20. All right, that's going to be approximately 0.733. Okay, and so now again, we found the answer to the question. 20 to what power gives me 9? Well, that happens to be 0.733 power. And again, that's approximately. Okay, I'm not doing this in Desmos, or I'm not showing you how it's done in Desmos or anything like that, right? So if you have questions about, like, if you're not really sure how to put it in your calculator, make sure you ask in class, right? Last one, we'll just go back to log. So using the change of base formula, log of the input, so log of 0.5 divided by log of 7, log of the base. Okay, again, so just put it in our calculators. Log of 0.5 divided by, divided by log of 7. It's going to be approximately negative 0.356 is our answer. Okay. And so 7 to that power will give us approximately 0.5. All right, so there was 7.5, everyone. Hopefully this sounds good. We went and used the properties of logarithms to expand and condense logs, and then we also kind of found a new way to calculate some of these logarithms when they're not always readily available on our calculators, okay? Remember that for these problems down here, I'm gonna want to see you doing this right here. The setup using the change of base formula, using either log or natural log, whichever one you like better. And then going ahead and calculating what those values would be, okay? All right, I'll see you in the next one. Have a good rest of your day.